I want to take a look at random variables and probability distributions. So with this idea, we first need to look at the definition of what a random variable is. A random variable, we usually write it as a capital X, is a variable whose possible values are numerical outcomes of some random event. Because a random variable is subject to randomness, it can take on different values. So let's take a look at an example of what a random variable would be. Alright, the example is if we flip a coin 3 times and wanted to count how many heads are flipped. The possible outcomes of flipping that coin 3 times are what the random variables are and getting a head. So our random variable here, x, can be, we can get 0 heads out of the 3 flips. We can get 1 head out of the 3 flips. We can get 2 heads out of the 3 flips, or we can get 3 heads out of the 3 flips. Those are all of the different possibilities. There are 2 types of random variables that we're going to take a look at. We have discrete random variables and continuous random variables. Let's look at the definition of each of those. A discrete random variable is a variable whose possible outcomes are countable numbers. We represent discrete random variables in a probability distribution table, which we'll be looking at soon. A continuous random variable is a random variable where possible outcomes take on infinite many values. We represent a continuous random variable by a probability density curve, and we're not really going to be dealing with too many continuous variables in this section. The first example says the number of flights delayed at an airport on a particular day. So the number of flights is going to be discrete. So I'm going to say that this is discrete. Because you can only have 1 flight delayed, 2 flights delayed, up to however many flights they have that day. You cannot have a fraction of a flight be delayed. The second one, the amount of gas used on a flight from Salt Lake City to Atlanta. So the event is how much gas is used on a flight. So the amount of gas that you can use 1 gallon or 2 gallons, but you can use any number in between those. So that would be continuous. The number of people who are going to who attend Disneyland on Friday, there's only going to be a discrete number of people, so that would be discrete. You can't have an infinite number of people, especially an infinite number of people in between 1 person and 2 people. And the last one here, the amount of time a family spends at Disneyland. So time will always be continuous. So that variable would be continuous. So that is the difference between a discrete and a continuous random variable. So now let's take a look at probability distribution. And we're going to be dealing with discrete random variables here. A probability distribution is a table where each outcome of a statistical experiment, X, is linked with the probability of that X occurring. Think of dealing with flipping a coin 3 times and how many heads we get, which we saw earlier. We can get 0 heads, 1 head, 2 head, or 3 heads. And we're going to look at the probability of each of those happening. A probability distribution has a few properties that go along with it. The first property is that the sum of all the probabilities in a probability distribution must be equal to 1. So we will write that like this. The sum of all the probabilities of my random variables x must be equal to 1. The second property says all probabilities must be between 0 and 1. So all of my probabilities of my random variables must be greater than or equal to 0 and less than or equal to 1. You can have the probabilities be equal to 0 and you can have the probabilities be equal to 1. However, if one of the probability equals 1, the rest of them must be 0. Or if one of them is 0, the rest of the probabilities must add to 1. So let's take a look at an example here. Let's set up the probability distribution for the number of heads that come up when we flip a coin 3 times. I'm going to let x, my random variable, be the number of heads that come up. So my random variable, if you remember back to the previous thing we were talking about, my random variable can be 0, 1, 2, or 3. So I'm going to put those values in a chart. Here I have my x for my random variable, and on the right side here it will be the probability of x. I can have 0, 1, 2, or 3 heads occur on 3 flips of my dice. Now we're going to look at a bunch of different ways to actually get that probability, but the easiest way for this example is to figure out our outcomes. So we can either have on my first flip a heads or a tails. With that heads, we can have a heads or a tails. With the tails, we can have a heads or a tails. And then my third flip can be heads or tails, heads or tails, heads or tails. I kind of ran out of space a little bit. There we go. Heads or tails. All right. Now, how many zeros heads do we have here? Well, we have 1, 2, 3, 4, 5, 6, 7, 8 possibilities. And the probability of getting 0 heads, there is only one instance, tail, 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 that has 0 heads. So that would be 1 out of the 8 to get 0 heads. Now let's look at 3 heads, because that's pretty similar. We only have one instance here where we have all 3 heads out of the total 8. So that probability of getting 3 heads would be 1/8. Now let's look at the probability of getting 1 head out of my 3 flips. I have head, tail, head. Sorry, that's not right. Head, tail, tail. Or tail, head, tail. Or tail, tail, head. That right there is 3 out of the 8. And then we can count whatever's left over. We have head, head, tail, tail, head, tail, head, head. So that would be 3 out of the 8. So this table that we've created with the random variables and their probabilities that go with them is a probability distribution. Notice that all of the probabilities are positive, and also that all of the probabilities add together to equal 1, because we have 1/8 plus 3/8 plus 3/8 plus 1/8, which is 8/8. All right, last thing I want to look at are examples of what is a probability distribution and what is not. So let's take a look at this first example here. The first thing for this to be a probability distribution is that each one of these probabilities must add to get to 1. So if I find the sum of the probabilities and I go to add all of them together, I get, let's see, 0.11 plus 0.37 plus 0.50 would be 0.98. So because that does not add to a probability distribution, this is not a probability distribution. All right, then second problem. this one's actually really easy to spot. If I look at each one of these, here I have 0.9, 0.6, and negative 0.5. Your probability here cannot be negative, so automatically this would not be a distribution. Your probability cannot be negative, so this is not a probability distribution. And I'm abbreviating that for space. The last one here, we have 0.26, 0.31, and 0.43. If we add all of that together, we get the sum of the probabilities is equal to 1. So this is a probability distribution because there are no negatives and the sum is all 1.